The next report will made by Bordyugov.
Hello, my dear colleagues. My name is Bordyugov Denis. I present the work that call the motion control research of the mobile robot with vibration propulsion device, which discretely interacting with the supporting surface. Mobile robots which move by means of vibration propulsion device are widely studied, and we can have various design and operation principles. Vulcan propulsion device refer to propulsion device that interact discretely with the supporting surface. The full cycle of their work consists of the reference phase, in which the transient properties are realized, and the transferred phase, when the propulsion device is transferred to a new position. Propulsion device implementing a similar mode of movement can be used, for example, when we're driving along the walls. The design scheme of a mobile robot with vibration propulsion device is a right body of mass m big and associate bodies propulsion device with mass m little, each reduced to the supports. We consider the translation motion of a mobile robot along the OX axis with walking propulsion device periodically interacting with the ground, simulated by an elastic viscous medium. The vibration interaction of the propulsion device with the body is taken into account by introducing of a power drive of the course motion, which creates force between them. To take into account the possible recuperation of power between the propulsion device and the body of the mobile robot, elastic bonds of stiffness C are introduced. Dissipative element with an equivalent coefficient of viscous friction make it possible to take into account the coefficient of efficiency of the drive to estimate the magnitude of the dissipative force mu and their powers. The introducing of the tangential force Rj take into account the interaction of the propulsion device with the ground. The force of resistance to the movement of a mobile robot depends on the speed of the course movement v0 in the form of function f big. Whereas phi0 and phi1 are constant coefficient. The equation of the motion of the considered mechanical system linking the speed of movement of mobile robot body v0, the vibration amplitude of the propulsion device ag, the vibration frequency of the propulsion device omega, and the amplitude of the driving force h big 0, and mode angle phi, which characterizing the step cycle of the propulsion device. Function f big 1, 2, 3, and 4 and 5 are determined by the dependence on the mode angle. Mode angle phi is related to the coefficient mode gamma by the ratio which present in this slide. It characterized part of the full cycle, then the propulsion device stay in interaction with the supporting surface. The problem is posed of researching ways to control a mobile robot with the walking propulsion device numbered and big, and choosing parameters for controlling the robot that provide a minimal of the complex criterion I, whereas h big 01, omega 0, v01, and ag0 reference parameters, and k1, 2, 3, and 4 dimension weight coefficient. The control parameters included in the definition of criterion I big, namely the speed of movement of mobile robot body, vibration amplitude of the propulsion device, oscillation frequency of the propulsion device, and amplitude of driving force. Weight coefficients are assigned expectly or depending on a specific task. The value of the weight coefficient is taken with the reduce of the numerical values of the speed of movement, amplitude of oscillation of propulsion device, frequency of oscillation of the propulsion device, and amplitude of the driving force. Algorithmization of motion for given design parameters as associate with the determination of the previous characteristics. Solution result. Numerical modeling of the motion quality indicator of a mobile robot was carried out for the following values of the parameters of considered mechanical system, which present in this slide. There we can see the amplitude method of vibration control on the walking propulsion device. In a first figure, we can see dependence of the amplitude on driving force H0, it's first, and the vibration frequency of the propulsion device omega, it's second. On the vibration amplitude of the propulsion device is Ag. In the second figure, we can see dependence of the generalized quality criterion for the movement of mobile robot on the vibration amplitude of the propulsion devices. The next slide is a frequency method of vibration control on the walking propulsion device. In first figure, we can see dependence of the amplitude of driving force Hb0 and the speed of the self-propelled vehicle V0 on the oscillation frequency of the propulsion devices omega. In the second figure, we can see dependence of the generalized quality criterion for the movement of mobile robot on the oscillation frequency of propulsion devices omega. In the next slide, we can see a high-speed method of vibration controlling on walking propulsion device. In this picture, we can see dependence of the amplitude of driving force Hb0 and the oscillation frequency of the propulsion device omega on the speed of self-propelled vehicle V0. In conclusion, I would like to say that the design scheme is proposed and the mathematical model of the dynamics of movement a mobile robot with vibration propulsion device is developed. Various ways of controlling the movement of mobile robot are presented. Introduced indicators and a generalized criterion for the quality of the dynamics of movement mobile robot. The dependence of the generalized quality criterion on the control parameters are established, the amplitude and oscillation frequency of vibration drivers. For the presented values of the parameters of mechanical system and the selected values of weight factors show the existence of optimal modes of motion corresponding to the minimum of the generalized quality criterion. Thank you for attention.
Thank you for your report. We have about 3 minutes for questions. Who wants to ask a question? Evgeny Magid. Eugene Magid.
Thank you, Evgeny Samuilovich. Thank you, Denis, for your talk. Unfortunately, I missed several slides, so maybe you already have answered my question, but just in case, do you use any simulation and what type of software do you use for your simulation? So to check the math.
Now, at the moment, I don't take any experiment and simulation, but I would do this for my diploma in that month. I start test and simulation. I would like to I would like take it in Simulink and other MathCAD program.
Okay, thank you. So Simulink with MATLAB may be enough to do some abstract testing. However, if you would like to move to realistic testing, did you think about, for example, gazebo simulation under robot operating system?
Yes, I think about this, but I would like to do this for my magister diploma.
Oh, so you are just a bachelor student now?
Yes, yes, yes.
Oh, okay, then congratulations. It's very interesting and good results for a bachelor student. It's really very, very good. Thank you.
Thank you.
Thank you. Thank you for your answer of this question.